Hi, this is Chris West from House Calls Vermont. Welcome to our second episode. We're still, sorry about that, we're still trying to work out a bunch of technical issues. I'm my own producer, which kind of makes things kind of difficult at times. So we hope that you'll stick with us. Jim is about to step in. Tonight we're going to have a show where we're talking about the process of going through an energy audit. We've spoken a lot about energy audits, and we've spoken a lot about that people should often get energy audits before making big decisions about making changes to their house. And so we're just more glitches here. Just trying to figure out where we all are at. Okay. There we go. And there's Jim. Hey,
Hey, everybody.
how's it going? So
Well, how about you, Chris?
it's going pretty well. We're at some point soon we should be able to do this live in person in a studio, but for right
Yes.
now we're stuck with doing it virtually. And of course, I'm apologizing for our learning curve on using the technology. Our
Well,
phone.
Chris, I always say technology is great until it's not. You know what I'm saying?
That's always true, isn't it? There's
It
no
is.
question about that. Um, so, like I was saying, today we're going to be talking about energy audits, the process of energy audits.
Oh,
We
but wait, Chris, audit sounds so oppressive. How about a home performance assessment?
I actually wrote it in the notes that it's also an assessment. Jim has got a long history of not liking that term, the home energy audit, because
Well, because
audits.
you think of a tax audit, and someone's coming for you instead of assisting you. So that's why I always like to go for an assessment because we're not just looking at the whole energy side either. We're not just looking at energy efficiency where we lose some people. We're also looking at the health and safety and also the durability of a structure and then the energy efficiency side of things because that's the golden triangle, if you will, that you've got to get those things right first. You want to make sure your structure in which you live, your home, is healthy and safe first, definitely durable. So you're making that investment once, not 15 times over. And then also at the same time, once you get those two things right, you're going to get energy efficiency by default. So that's what you and I both have subscribed to,
Yeah.
and we know that works.
And it just seems a little less painful to call it
Yeah.
something other than the audit. Agreed. And after our discussion about energy audits and taking whatever phone calls come in, our number is 802 200 2550. And we're still getting used to that software, so please bear with us if you call in.
Yes.
After that, we'll be at the 8 o'clock hour. We'll be having a guest on, a pre recorded interview with Rob Conboy of Glavel. Glavel is a new type of insulation. Actually, as Rob describes it, it's been around since the 1970s, but it's a type of insulation which we're going to be having made here in Vermont. Essex, Vermont is where the factory will be,
Yep.
and we'll spend the last half hour talking to and listening to Rob and understanding and learning more about this replacement for below grade insulation. Right now, our options are foam or no insulation or interior insulation, which is also an option, obviously.
Sure.
But this is a product that I'm really excited about. So stay tuned and listen to that at the 8 o'clock hour. But Jim,
So Chris,
today, yeah, go ahead.
if you're concerned about your home and you feel the temperatures getting colder and you see the fuel prices rising, usually that is the motivation factor for most people wanting to have some type of energy audit so they can spend less on fuel usage. But there's other reasons too. So if you're calling in and you're a concerned homeowner, you did this yourself. This is how we got engaged in our professional relationship. Is by you calling me and us engaging with one another to make changes to your home. I mean, what is your motivation factor when you're calling in for a home performance assessment?
Yeah, so doing an energy audit is, well, as Jim would prefer to call it, a home performance assessment. What actually happens during a home energy assessment? What's the process you can expect to go through from hey, I want a home energy audit for whatever reasons. I'm uncomfortable in my house, or I think that there are health and safety issues, like we all start going inside for the heating season, and suddenly everybody comes down with a case of lung infection, or just feeling ill, and so while we're going through this, we want to start from that moment. Hi, my name is X, and I am uncomfortable, or I have issues, or I've noticed durability, I've noticed rot on my house, or mold in my attic. I want someone to come and take a look. So what happens, Jim, from that first moment?
Well, we usually first try to understand what type of structure you live in. Okay, so is it an old historic farmhouse? Is it unfortunately a log cabin? Is it a ranch?
Wait, why don't you like log cabins? We'll get back to that just a second.
There's lots of reasons why, and I feel so sorry for those people. But anyway, there's also the raised ranch, the traditional New England Cape. There's a colonial. There's a contemporary, which contemporary you would think would mean what is the design today, but that term has been around for a long time, and so contemporary is just usually a different design than what is historic. But there's several different structures, so we try to identify what's there. And usually, since we've seen so many different homes of each type, we can pretty much dial in from there. Like with a cape, we know what can be expected with knee walls, with sloped ceilings, with the type of roof system they may have, with the basement structure, with the farmhouse. We know that traditionally they're either going to have a stone rubble foundation, or maybe they've had improvements during the years where they've lifted the house, cribbed it up, if you will, took out the stone foundation and poured concrete in there.
Or added brick as an air sealer in the 1920s. Yeah.
Great point, Chris. Yeah, definitely. Because a lot of people think that brick in their old farmhouse was structural. And in actuality, that was used back in the day by masons to provide some type of air sealing, because they knew that air was chasing in through the house and chilling down the basement and the rest of the house at the same time. And so, but in reality, that usually provides a mouse superhighway in between the brick and the stone. So that's
there's a graphic in my head that I'm going to put on the post-production of this, of a mouse superhighway. I'm just saying.
There you go. But then, you try to ascertain what type of structure it is, and then immediately you key into some of the possibilities, and then you start to quiz the client of what they might be experiencing. Like with a farmhouse, you may find out that they have a dirt floor still, and they want to tighten up their home. Well, tightening up their home and making it less leaky would be horrible in many respects, because if they haven't dealt with the exposed dirt floor in the basement, they're going to have a huge moisture uptake inside that structure, which is going to cause a lot of problems inside if you just tighten it up. So you have to look at the house as a system always. And so once you know what type of structure they have, and you identify some of the key areas, you usually get a lot of aha moments with the client over the phone. Is, yes, I'm experiencing that too. And yes, I need to correct that. And yes, I'm seeing condensation on the inside of my windows. And yes, I'm seeing very long icicles in certain winters on the outside of my roof structure. So you usually can initially identify what's going on, and then get them to be willing to engage in the rest of the process.
So when we're, let's just say, okay, I am X, and I call up, and Jim makes or I make a couple of requests. We want to know some basic information, like, where is the house? How old is the house? Have you had an assessment done before in the past? What are your chief complaints?
Energy usage.
Just very high level stuff to start with, and then we take a look at our schedule, and we schedule a time to come. What are the things that we always say to someone before we go and begin our audit process? What are the top 3 things we ask them to do in a heating season, of course? And what are the problems with doing audits during certain times of the year?
Well, first and foremost, and I've made this error a couple times myself in forgetting as we transition over from one season to the next, is you have to make sure if they have a wood burning heating appliance, like a wood stove, a chimney, or whatever, even a wood furnace, you have to make sure that those are extinguished before the audit is performed. And that means not just open flame, but coals as well. So, because if you don't and you put the blower door in place, then it can actually bring down combustion appliance gases or smoke into the house, and that could be not a good thing. It's kind of embarrassing. So you want to make sure that is addressed. You
And
also want to
that's
make sure,
because part of the process is a depressurization
yes,
of the house.
yeah, you
So
reverse the flow of the chimney when you're doing the blower door.
right. So that's why we need to have no um, even ember based fires in a wood stove, in a fireplace. Pellet stoves are different because they're almost always sealed combustion. But if they aren't, then even a pellet stove would be something we'd want people to refrain from using for a number of hours before the audit begins.
Certainly, but you also want to make sure that all the windows and any doors or any other type of opening to the structure is closed and latched. Most people think that their window latches are for security. That's true, but it's also for making sure that the weather stripping on the window is tight. And so you get less air leakage. So you want to ask if they can check that before you get there. It doesn't have to be done way in advance, just basically maybe an hour before you show up. And you also need to make sure that the temperature differential is correct. And why this is important, because we use an infrared camera to scan all the areas of the home, from the attic surfaces to the wall surfaces to the basement areas. And you want to make sure that the temperature differential is at least a 5 degree delta, because it allows for the infrared camera to take appropriate pictures. And what people don't realize is, now granted, if it's 65 degrees outside and 65 degrees inside, there's really no delta. But if you have a good solar gain because the sun has come up and it's shining on the roof, and you put the blower door on, it's going to be bringing that heated attic air into the house more quickly, and will indicate areas of air leakage very well with the infrared camera scan. Because what happens is, when you have a roof system, it may be 60 degrees inside the house and 60 degrees outside, but the attic temperature could easily be 80 to 100 degrees, and that's enough of a differential to show where air leakage pathways exist. So we just want to make sure that the conditions are right for the infrared camera scan to work appropriately. Even though we use a very sensitive camera, you have to make sure that the properties are correct when you're doing this.
So if, for instance, the outside temperature when we show up is 62 degrees and the inside of the house is 62 degrees, we're the infrared camera. So part of the process, and we'll get into the deeper, but part of the process is we're going to drive air by sucking air out of the house, and that will suck the air that's outside through all the little gaps and holes throughout the entire house. And we're using the infrared camera to tell us where those are at. The blower door itself gives us a number, and that number is translated into the total air leakage of the house based on volume. But we can't get infrared pictures if the outside temperature and the inside temperature are the same temperature. We need a delta T, a temperature differential of at least 5 degrees, and the bigger the temperature differential, the better and clearer the images are.
And so, Chris, sometimes people ask, okay, should I have my audit? Is it better to have my audit during the winter, or is it better during another time of year? Quite honestly, as long as we have that differential, it's a stellar time of year. And as long as you understand, the heat that is developed by direct sunlight, because you could have a 65-degree temperature inside and outside and a cloudy day and not get great results with the infrared camera. But if you have 65 degrees outside and inside, but a good sunny day, that won't take long to make sure that the pictures are going to be great, because it's going to heat up that attic air, and that'll show air leakage into the attic very quickly.
Right. So, okay, I'm on the phone with Jim. Jim and I talk about, I am client X, and Jim and I talk about the age of the house, as we said, and what the concerns are and why they want to have the audit. And Jim
Sure.
picks a day, and it happens to be a day that we don't have to cancel. We've had to cancel audits because we woke up and the outside temperature was about the same as most people's inside temperature, and we're like,
Sure.
we either have to wait 3 or 4 hours for the temperatures to change, for the sun to to increase the temperature on the house and in the attic and things like that, or we need to postpone. It doesn't happen very often, but it does happen most often in what we call the shoulder seasons, those spring
Yes.
and autumn seasons. But after we make the appointment and we show up, what's the first thing we do other than, hi, my name is Chris and this is Jim and we're here to do your audit? What do we do next? The next part is,
Well, sure. We're gonna, since we're already outside, um, before we carry in equipment and have to take shoes off and everything else in Vermont, we want to go ahead and walk around the outside of the house. And we ask the customer to be part of the process. I mean, that we've done some audits where the customer says, I can't be there that day. Can you just go do the test and tell me the results? Well, that's great for us because it makes for a very quick audit. But on the other side of things, it doesn't allow that educational component and then engagement with the homeowner to know what they are experiencing. So what we try to do is at the very forefront of the audit, when we first walk up, is we say, okay, can you tell us about any compelling issues that you're experiencing outside of the home? Like, is there rotting siding? Would there be any icicles that you see forming? Would you have any penetrations in the home that you're concerned about? Do you have water issues in your basement that might be associated with grading issues outside or improper drainage, that type of thing? And then we'll take a look at the outside and we'll look at the siding. Because a lot of times the siding and the paint on the siding is failing prematurely. And there's reasons for that. There's vapor drive reasons. There's also the fact that the siding wasn't back primed appropriately before it was put up, and there's no rain screen in place. And so that helps us identify some of the durability issues that they may be having, plus some of the heat loss issues that they may be experiencing, especially with shingles. So when you show up with a metal roof isn't going to deform the same way asphalt shingles will. But if we look up and we see that the shingles are already deforming, and yet it's only a 5-year-old or a 15-year-old roof, and it should have lasted 30 years to 40 years, then we're going to understand that there's some heat loss issues going on in the attic. And so we look at some of those things, and also where rodents could be infiltrating, because rodents are insidious. They will get into areas, chew apart wiring, destroy insulation, cause a lot of durability issues. And so that's some of the initial review we'll go over with the customer and ask, once again, what are their concerns, and get a better picture of what's going on with the structure.
yeah, so basically we do a visual non-destructive, which means we're not going to pull anything apart without talking to you, analysis of the outside of the building. And sometimes as we're going around, we'll notice something. We'll say, would you be okay if we pulled back the siding here?
Exactly.
We'll put it back, but is it okay if we take a look at this?
Chris, we did that audit recently on a home that was very tight and was a post and beam that looked great.
Yep.
But yet behind the scenes, we could see a little bit of the sheathing that was rotten. And I took a pocket knife and could penetrate very easily through the siding, through the sheathing.
By the way, a very important, inspection device, having a pocket knife.
Oh, certainly. But yet we know there's problems there. So we're going to look at issues with siding and shingles, but also window trim at the same time. I mean, there's so many windows I've looked at that they look somewhat compromised, so they keep getting painted, and so it doesn't look so bad. But you take that pocket knife again, and when you bury it to the hilt, you've got some moisture issues and rot and deterioration behind the scenes. But then you also want to look at like any type of bath fan vents. You want to look at laundry or dryer vents. And sometimes, I mean, you were just on one recently, Chris, with me, and we saw that the dryer vent was completely blocked. And so why is that important? Well, it makes the fact that the dryer can't vent all the moisture out as efficiently, and thus you're going to increase the amount of gas use or electric use to dry your clothes. So it's going to take longer. So making sure that's unblocked is really hugely important at the same time.
And depending on the type of fuel you're using, it can be a fire hazard.
Oh, true.
You've got
Very
lint, which is very flammable, building up. Yes, you're asking the blower fans to work harder than necessary, which in and of itself is not good for the overall system. But the lint can just be a fire hazard as well. I was thinking also things that we've noticed. If your siding of the house is too close to the ground,
Oh, sure.
rain will hit and bounce back up onto the outside of the house, and if that doesn't have an opportunity to dry properly, then you can have wood rot issues, and that's almost always, with very few exceptions, where the perimeter joist bay and joist beams and other types of structures are that make up the floor of the wooden part of the house. You're going to have the bottom part of the house, whether it's on slab or it has a basement, is going to have something that's very good in working against moisture, like concrete or
Yep.
concrete masonry units, also known as cinder blocks, or whatever. And the transition from that to your wood, which is then very susceptible to that type of non-drying condition, if that's within 6 inches of the ground, that's going to stay wet, and you're going to see degradation along that particular part of the. Oh, great! Ob's disconnected and is reconnected. Anyway, we're just going to assume it's keeping going.
Yeah, but at the same time, what we see in older buildings is if that condition which Chris just described is happening, where you're getting that splashback onto the wooden structure, and then somebody says, well, I'm going to make your old structure really, really efficient because you had either bad insulation or no insulation against that 8x8 box beam on top of stone foundation, that they're going to foam that solid. You just shut off a drying plane to the inside of the basement with spray foam, which it can really provide great insulation properties, but at the same time it limits that drying potential. So when that water gets in from the outside and gets into that beam and has nowhere else to dry, it's going to start to rot that away very, very quickly. So this is why when you do this assessment, it's not just about efficiency first. It's about health and safety and durability first, and then also making it efficient at the same time.
Yeah, and we've also looked at whether the chimney is properly chinked.
Oh, of course.
You've got to make sure that whatever you see that is a durability issue, we're going to point out. Now, we're not the people going to go and repoint a chimney, but
No.
we are going to tell you that the chimney could use some repointing, and leave it at that. Leave it to you, and even give you the names of some people who can do that work, maybe. But
And that's why, Chris, I say this is not just an energy audit.
yeah,
This is a home performance assessment.
right.
And what is so important about this is when I first took my training for BPI, which is the Building Performance Institute, about being an auditor and a home performance assessment person, more so a building analyst and a heating system analyst, I realized that I got out there, but I was green in this field at the same time. I didn't know enough. I knew a lot about building a building, but I came to understand that you really have to have more experience in this field. And you have to understand, once again, and have this ingrained within you, how does the house perform as a system?
Yeah.
It's not just about buttoning it up and make it tighter if you have these durability issues. If your chimney's not flashed, if a dormer to roof junction is not flashed appropriately, and you're getting moisture in there, you're going to make problems worse if you don't understand what's going on with the house first and foremost. And so having that greater building structure understanding and also building science understanding is crucial about building a structure, but also improving a structure. And, currently in the state of Vermont, there's a bill going through S109 about providing a lot of money to make 120,000 homes in the next 10 years approximately weatherized, without the proper attention towards making sure they're safe at the same time.
Well,
So that's
hopefully that component will be included.
and that's why we're being very vocal about that, for
Yeah,
sure,
yeah.
because we don't want to just tighten up a structure and make it like an ice chest if there's a lot of other durability issues at play and health and safety issues. So
Yeah.
that's really important at the same time.
Yep, and we were actually both involved in that process. So hopefully Jim and
Mhm.
I will be able to keep our fingers on the pulse and make recommendations to Efficient Vermont if they're the ones who end up putting the program together. And we're doing a lot of research on that. We're finding out what's already out there. The
Sure.
WAPs have a lot of very good information. We got a manual the other day from one of the weather assistance programs, the WAPs, a 220-page manual on what they train their weatherization technicians to learn. and we were asked to give our opinion about that. So
Which is great.
yeah, we're very excited
So what
about
about,
it.
Chris, though, when we come into a basement where they're still heating with oil and we see the big oil tank in there, but instead of black iron pipe, we see copper, in which we saw this just
We
the other
we
day.
did see that the other day, and we know so a copper feeding tube or filling tube and a copper air release. Because as you're filling a 275-gallon tank with oil, it's not full of nothing; it's full of air. And as you're displacing the air, there has to be a what they call a bleeding tube, which allows the displaced air to go somewhere. And those are required by code, by law, to be black screw type fittings and pipe, and oftentimes the old fashioned ones are copper, and the copper is just not strong enough to handle some of the pressures that happen, and so
Exactly.
we fear corrosion, but we also fear leakage at the various joints. So that's one of the things that we're also looking out for, and that we see from the outside as well. Okay, so we're outside. We've done a walk around. We've noted exactly what it is that we've seen as we're walking around, and we're ready to go inside. Yeah, what's
But wait. You've noted this several times about gutters and sealed combustion pipes, because sealed combustion pipes are the white PVC normally pipes that sometimes it's just a single unit with a intake and exhaust, but sometimes you see the big snorkel looking white PVC pipes, and some vent appropriately, some actually self-feed, so your exhaust goes right into your intake, which isn't great, or they're so low to the ground that when the snow gets built up, they'll block the ability for that to actually function. So think about if you're snorkeling in the ocean or a lake, and all of a sudden your snorkel, you go underwater too far and it gets plugged with water. You can't breathe, and
right?
nor can your heating appliance. And so that can cause issues. At the same time, with durability of water and moisture intrusion, if when the water comes off your roof, if it's hitting the ground, splashing back, or it's eroding the dirt away, which we saw this last Saturday, eroding the dirt away from the side of the house,
Yeah.
then water is more prone to pool in that area and then find its way underground. And water's insidious. It'll find the path of least resistance. And if it can get into your basement, it will. And when it does, it causes issues.
Yeah.
So those are some of the major items, as Chris was saying, that we look at on the outside of the house. So it's pretty comprehensive. And that's before we even get inside and look at the rest of the house.
And I just remembered another one. From the outside of the house, we can tell whether the attic, if it is an attic flat, is vented with ridge and soffit vents,
Very
or
true.
with gable end vents, or both, which we often see, which we can explain at some point why that's not a great idea. Okay, so there are a lot of things that we can tell about a house without even stepping inside, and that's where we start.
Yep.
And then I go back to my car, I get my backpack, which has my computer and my measuring devices, and Jim unpacks all of the audit equipment, and we go into the house.
Yep.
So what's the first thing we do next, Jim?
Well, usually we like to do a walk around with the house, and still we're continuing the conversation with the homeowner and asking them what are they experiencing inside. We let the nose knows. Chris says this often. When we go into the basement, if we start to smell mildew or mold, you're going to know pretty quickly. We also look for any mold issues inside the house, or sheetrock delamination. Because when that starts to happen, that could be, caused by several reasons, but sometimes it's a moisture issue at the same time. We're going to look for cobwebs. Yes, spiders are great because, a spider will develop a web in a leaky area for airflow, because
An
it
air stream?
realizes
I think you always call it an air stream.
an airstream, because it knows something's going to fly by eventually that it can eat. And so it'll form its web in the highway of air. And so if we see those, it's not just bad cleaning. It's more so that's what's happening, because instinctual elements of the spider will indicate where the air is leaking. So we're going to look for those indicators. We're also going to look for mold around windows. We're going to look for several things and inside the house. And we'll also keep our eyes open for health and safety issues, like
Yeah.
a CO detector. Is there one in place, and is it operating appropriately? And in the basement, when we go into the basement, are we noticing standing water? Are we noticing mold? Are we noticing other issues that exist, in that area before we ever do.
Is there, like you were just saying before, is there a dirt floor? And some people are like, what's the
Yeah,
matter with
exactly.
a dirt floor? Well, a dirt floor is actually um, always moist, and it's getting that moisture from groundwater. So you're just adding a moisture load to your basement, which then, of course, adds moisture load to the whole house, depending on
But
how the basement
Chris,
and
what if my exposed basement floor, which is dirt, is dry looking? Is that still an issue?
absolutely, because that we're getting a snapshot in time.
Yeah.
You're gonna have if we're there during a very dry part of the year and it hasn't rained in weeks, which of course we have experienced here in Vermont on a semi-regular basis. Um, uh, what happens during mud season when you have the snow melt and the rain at the same time? We don't trust that you're not getting moisture into that space with a dirt floor, even if the top inch or two seems to be dry at some particular points in the year.
Exactly. Hey, Chris, have you noted the call-in number yet?
Oh, I did, and I called it out. Let
Okay.
me do that again. The call-in number is 802-200-2550. Please call in if you have a building science question you'd like to ask us, and we'll put you on the air and answer your question.
Yeah. So after we do that, we're also, as Chris is setting up to do his 3D model of the home, and he uses SketchUp very effectively. And that gives us a great metric for not just the geometry of the house, but should other elements need to be addressed, whether it's insulation, whether it's siding, whether it's sheetrock. We already have those measurements in place that will also be an asset to the customer on the other side of things. And so it's really a great resource. And then also when we're trying to explain things, because see, I've heard some say that you have to hear something 16 times before you actually will learn it effectively. It's not as extreme in all people like that, but for some it is. And so being able to give not only a conversational explanation of what's going on with the home, but also a diagram or a visual is crucial. And Chris does a very effective job at that of pointing out the sometimes 5 or more different attic areas or basement configurations that might exist and where we're actually discussing to have changes affected. And so that is something that he starts to develop while I am definitely setting up the blower door test. But sometimes what I'll do while I'm setting that up, if the geometry is more challenged in the home, it's going to take Chris a little bit longer. I'll start to go out and look for if it's a propane or natural gas.
Wait a second.
Just
You mean like a Victorian?
No, not a Victorian. No, I'm talking about the multi-functioning tape slash I wanted to put as many dormers in place as possible type of home and contemporary slash very confusing type geometry.
Yeah, we've had it all. I've had houses where I walk in and I thank my stars that it's just a rectangle, maybe 2 or 3 rectangles stacked on top of each other, but just a rectangle. There are some automation ideas that I've looked into on doing the volume of a house, but as of right now, I'm still going through with my little electronic distance meter and
Yep.
putting together a model based on that. And it may not be 100% accurate, but it certainly is accurate enough for the work that we're doing. And it's
Oh, but
more,
the visual aids, Chris, that it provides, to the building science person, but also to the layman,
yeah,
is hugely beneficial at the same time.
yeah. We'll put a stripped down, no information copy of an audit we did on the House Calls Vermont comments for this video, so you can take a look at what our audit reports look like. We are one of the few teams in the EEN that actually draw a 3D SketchUp model for every audit. Not that that makes us better, but it is something that we find to be very effective, because not only am I getting, I'm not only capturing the volume and the interior condition floor area, otherwise known as the square footage of a house, but I'm also able to then have the areas for those things when we're doing pricing. So I can
Exactly.
look at it and just go, oh, and when you're looking at a house, you may not notice that there are 5 different attic conditions. You may say there are 3, but once I'm really in it to it and I'm looking at how the roofs go together or communicate or not. I can discern very small differences which are significant, and each require a different application of remedies in order to work right.
Yep. But we also, at that time, we reinforced our questioning of the homeowner as to what were the main reasons why they wanted us to be here at their home. Sometimes they'll tell us up front that they have some icicle issues. They have some really expensive heating or electrical bills. But then when we're in the home, we ask about comfort issues. And a lot of times they'll say, you know what, I also see this breeze or feel this breeze going by this area of the home during the heating season, and I don't know why. And so that helps us key in to some possible areas that we would not normally find. But I don't know of any audit that I've ever done that there wasn't the aha moment, something that even though the homeowner said, I know where all these issues are happening, I know what I need, but then you get there and you start to show them what is actually happening behind the scenes. They say, oh my gosh, I did not realize, but that makes so much sense. And so that's what we're keying in on at the same time. And also on the inside, we're going to ask them, are they seeing, once again, the condensation on their windows? The person we did an audit with this last weekend had mentioned that he's going around to all the windows and wiping up the condensation.
It was so cute. He was really, he's a dedicated parent. He saw condensation on the bottom inch of the windows during the winter months, and he was like, okay, I'm going. He was going around with a rag, wiping that off every time. He was like, what can I do? Can we reduce the moisture in the house in order to get it to the point where that's not happening? The answer is yes, but not that during the winter time, that level of relative humidity that would be low enough so that you weren't getting condensation on those windows would make you uncomfortable. You'd be in the 10 to 15% relative humidity range, where people need to be between 30 and 60 to be comfortable. So sure. It's a very gallant effort. And the answer is, and you can go back and look at our episode on windows, and we'll do another one at some point here on the live stream, but basically it's the thermal conductivity of the window that's not good enough to resist the cold or the heat leaving the house at such a rate that the inside surface of the window is below the dew point at that little strip. So not the answer he wanted, but at least he knows what's causing it now.
Yep. And one of the other things we've adopted more recently in the last year, we used to do inspections of basement and attic areas after the blower door, but we found that, and we'll get to what the blower door is in a few moments, but we found it being a better option to do those inspections first. So what we'll do is we'll poke our head up into the attic, if there's access, of course, and to see what the insulation types are, whether there's air sealing that's been, properly addressed, and also is there proper ventilation in the attic. We'll do that first and foremost and see what the condition of any attic access is, whether it's insulated and weather stripped, whether there's mold in the attic. And if there is, that's usually indicative of the fact that there's been a lot of heat loss from the living space into the attic and causing condensation and thus the mold component and how that can actually re-infiltrate into the living space. We'll also look at the basement areas, see what type of basement it is, whether it's a rubble foundation, concrete masonry units, which are
also in the cinder blocks. Yeah,
cinder blocks. Whether it's going to be a poured concrete or something different. I've seen just a stacked foundation without rocks, but anyway, it just is not the great foundation to have underneath the basement, or whether it's just a slab on grade. But we'll look at those components first and foremost and get a better understanding of the building once again before we start. But then after that, usually what we
we use a term there often. Before we start driving air, right? We're taking a look at the situation before we start sucking
the pre-blower door infrared camera scan, if that's what you're talking about, Chris.
Well, everything we're doing up to this point is pre-blower door.
Sure.
And there are times, although we don't do it at every audit, there are times when you feel that a pre-blower door infrared would give us some good information. So we can see what's happening at what they would call N natural, right? The natural pressure differential outside.
Yes, so sometimes that blower door or the pre-blower door infrared camera analysis won't show you attic leakage normally, because what's happening is because the stack effect, which is stack effect, think of a big hot air balloon on the inside volume of your home. And so the basket or the gondola is in the basement, and then the neck of the balloon is, like starting the first floor and then going up, and then the top level of your home is the rounded part of the balloon. And so that's where the greater pressure is, and it's trying to push out. And so since it's trying to push out, usually you don't see that air leakage at that point in time. What you do see is the reinfiltration of air through wall assemblies, through basement assemblies, because as that air is pushing out and depressurizing the internal space of the home, then the home wants to re-equalize just by simple physics. It wants to create an equilibrium of air pressure inside the home, so it's drawing air through the leaky spots of the home, just as it exists without wind blowing or without us putting a blower door on there. So that sometimes allows us to key into several key components of how the installation is performing, how things are air sealed, and how things are not air sealed well before we ever put the blower door on. And then when we do that comparison of pictures before the blower door is put on the home and then depressurizes the home more aggressively, and compare that to when the blower door is actually operating effectively, it really provides some really compelling images.
Yeah. So there we are. I'm walking around, taking my images, writing the stuff down, building a SketchUp model. Jim is putting the blower door up, and the blower door is got a frame, and it's got a red, what we call a shroud, and it's got a blower, a fan, which has.
But Chris, why is it red? Why is it red?
So that people don't try to open it during the
No,
test.
actually, I heard back in the day when I was going through training, they made it red so that when your neighbors drive by, they see this big red shroud in your doorway, and then they say, "Hey, Jill, Joe, whatever, what was that in your door the other day?" "Well, I was having a home performance assessment done." "Oh, tell me more about that." An advertising thing. That's why it was made red.
Okay. Okay. Well, so now we're in the house. I've got the measurements. I'm sitting down at the kitchen table, trying to get the SketchUp model built. Sometimes easier than others. I'm speaking with the homeowners about making sure that they can get the fuel usage to us on all the different fuels that they use to heat the house and for domestic hot water, if that's something separate. And then Jim is putting the blower door in. Now, the blower door sounds like a very dramatic thing, and it is in and of itself. But the blower door itself, the test for the air leakage only takes about a minute once we have the blower door properly released and set up. And so we put the blower door in the one of the doors. It is a door. There are blower doors that go into windows in case although we don't have one that small for our setup. But the blower door is also attached to a manometer. A manometer is something that can test pressure differentials. So we make sure the doors and windows are closed to the outside, and we start the blower door test. And the blower door blows air out of the house, depressurizing the house, and putting the number of cubic feet per minute that it's blowing over the fan. Now, it actually isn't testing for cubic feet per minute. It's not counting every cubic foot, but it is got pressure taps, and those pressure taps have been calibrated so that when those pressure taps are seeing a certain pressure differential, that means that fan with that particular opening is pushing this much air, and that gets printed out or there's a readout on the digital screen, and that allows us to know how many cubic feet per minute are going out of the house. Yeah, cubic foot.
1 foot by 1 foot by 1 foot.
1 foot by 1 foot by 1 foot. And once we have that number and we have the volume, I can show through a calculation what that air leakage number is. And that air leakage number is going to be given to us in what's known as air changes per hour. And air changes per hour at 50 pascals, which is the pressure differential internationally recognized as the one we do for blower door tests, is the same as an estimated 22.5 mile per hour wind blowing against the house. So during a 22.5 mile per hour wind event, wind is blowing against the front of the house, which is actually a positive pressure, and on the back of the house we have the negative pressure. So we're kind of doing half of what wind really does at that moment. And what that's going to do is going to tell us where all those, at least how big those leaks are. And we can do what's known as an equal leakage area, which is where we take that number and we make a calculation. And that calculation says that if your house is 2,200 cubic feet per minute at 50 pascals, that means that you've got a 220 square inch hole in your wall, which is like 24 by 24 all the time.
Open a window.
If you
Open a window all the time.
Right. As an open window, if you take all of the little cracks that it's sucking air through and add them up in area, that would be whatever that is. Now, each air leakage number will give you a different size. A very, very tight house might have only a 5 by 5 inch hole if you were to take all the leaks and put them together like a passive house. And some houses have really, really big ones, like 3 feet by 3 feet. We even had, very early on, we had one customer who literally had a 2 by 4 foot hole in the roof that was open up to the outside. So
but to give an example, Chris, real quick, if we're building homes today that are really high performance, we may expect to see, depending on the volume of the house, of course, and the square footage of the surface area on the 6 sides, we may see definitely lower than 100 cubic feet of air leakage per minute. You know, we're trying for, passive house standard is 0.6 air changes per hour or less, but that may equate into, I've tested some homes as low as 30 to 40 CFM of air leakage, but I've also tested homes over 10,000 CFM of air leakage. So
the machine maxes out at 6,500. So that was a double blower door, I'm sure.
It was because it will help you extrapolate up to that point, but then you realize, hey, there's a lot of opportunity here. It doesn't mean necessarily you're going to take an old farmhouse that was maybe 8,000 to 10,000 CFM of air leakage and bring it down to the 100 mark, but you can at least decrease it by half the air leakage and really improve things with the home. So that would improve on comfort. It would improve on heat usage or fuel usage at the same time. And so definitely understanding what that is. So the blower door is a great diagnostics tool to help us establish that baseline of air leakage, which on the other end, once the improvements are made, you do that test again and say, okay, this is how much it's been improved by. But at the same time, Chris, the blower door is kept on after we use it for that initial blower door measurement for the air leakage of where that baseline is for the next test. And what would that be?
So the next test is walking around with the infrared camera. You know, we set the blower door up and we tell the manometer to tell us how leaky the house is. But we want to continue to drive air because it's the driving of the air that has a temperature differential, whether warmer or colder than the interior air. That's going to show us where the leaks are using the infrared camera. So then we turn it down a bit to like 30 pascals.
Yep.
And then we walk around the house with the infrared camera and hopefully with the owner, and we take images around the house. And based on the images, we're able, it's kind of like an x-ray in a lot of ways. We're able to see inside walls if they're framed walls. We're able to see if you have structurally insulated panels, we can often see where those panels go together. We can see where the builder did or didn't do a good job air sealing the perimeter bays of every floor. As you're going up, you have, you know, the floor, then you have the ceiling, the walls of the floor and the ceiling, the floor, and you have that bit in between that forms the floor of the next floor. Well, that is surrounded by a perimeter joist, and that perimeter joist is then either well sealed or not. We see a lot of air chasing from the outside. Depending on the type of construction, I can think very clearly. We can see knee walls. We can see all kinds of things, and it allows us to create a good picture of exactly what's going on inside the house.
My two favorite, though, Chris, would be when we actually find rodent activity. We always say that it appears like there's rodent activity.
Well, but last weekend, one of the owners, one of the clients who invited us in was saying, I've been hearing them in the walls. We thought they were mice, but then we trapped one and realized that they were bats.
Yes.
And so they want to do whatever they can to protect these bats, but they also don't want the bats in the wall because all rodents, as Jim is very fond of saying, have no bladder or fecal control. They just poo and
Exactly.
pee wherever they are. So
Yeah.
if you have air moving through a fiberglass filled cavity that's got rodents living in it, then you are actually breathing and inhaling some
Sucking
rather
it in.
nasty stuff.
Oh, yeah. But
Um,
also the other thing is the infrared camera that I bring to the audit is was originally a $14,000 instrument. Okay, so we say this is the most expensive stud finder that's out there because of thermal bridging. Because
yep.
thermal bridging, wood is less insulative than actually insulation is. So normally, in normal conditions, when you're looking at an exterior wall, you're going to see that the um, internal stud shows up as darker or purple usually, in the depending on the scale you're using for the thermography. And then the actual stud bay is going to show up warmer or more yellow temperature. And so when you see that, though, you can say, hey, if you want to hang a picture, today is the best day you can do it while we're here, just because it does indicate these things. But also one of the things it's done so many times is it will show water leaks, whether it's from a closet or closet flange from a toilet on the second
With
floor,
Rob
and then all of a sudden you
Conboy.
see in the floor below, there's perfectly round stain, or on a roof line, you see the same thing. It'll show evaporative cooling. So think about how you make ice cream. What you're doing with ice cream
How
is
do you
you're
make
putting
ice cream?
well, you're putting ice around a container and you're using salt to melt that more quickly to pull heat away, and it creates a cooling effect. So the same thing that happens when water is in an area and it starts to evaporate, it pulls that heat away. So it shows a colder, cooler area, and the infrared camera picks up on that. So many times we have found issues behind the walls that were moisture related, not thermally related, and that is a great diagnostic tool at the same time.
And oddly enough, when you see that for the first time, one of the things you can notice is that all water drips form circles.
They
They,
do.
they form perfect circles if it's on a flat surface. Sometimes a
Yes.
little elongated one way or the other because of whatever is on the surface that you're looking at.
Yep.
But it's great for that. We're about 7 minutes away from our interview, so I just wanted to kind of tie a knot on this. So we've got the infrared camera analysis, we've got the information on the fuel usage, we've got the model that we've built. We ask for very kindly for payment, and we say it's going to take us a couple of weeks to get you an audit, mostly because I spend a lot of time making sure the audit is very comprehensive. And then we leave.
Combustion safety analysis,
Right.
heat system analysis. That's
So
something we do.
there's one last thing that we do is that we have some sniffers. So if you're using propane, we go around the house. We make sure that none of the connections are leaky, and we also test your combustion appliances. So your boiler, your furnace, your
Yep.
domestic hot water heater. If your oven uses natural gas or propane, we check that just to make sure that how they're operating. For instance, if you have an atmospherically vented boiler and you make your house significantly tighter, you may have a problem with draft. And the draft is how aggressively the chimney sucks on the gases that are put into it. That's not a problem when you have either a power vented or a sealed combustion unit, but in atmospherically vented systems, if you make the house tighter, you may be creating a problem with that combustion appliance
Backdrafting.
being able to work and backdrafting. As a matter of fact, the house we were in a couple of weeks ago, 3-4 weeks ago now, the house was so tight that they couldn't keep the fireplace going.
Yeah.
And he was like, if I crack the door, it works right there, but as soon as I close the door again, it stops working. So it's very important to know when a house is too tight. We're a house that is very leaky, and even if you, let's say, 10 air changes per hour at 50 pascals, and you're going to reduce that air leakage by 50%, you're still at 5 air changes per hour. And houses don't have problems with indoor air quality until you get to 2 air changes or tighter. And so this house we were at a couple of weeks ago, even the one last week, are around 2 air changes per hour. So we're concerned a
Sure.
little about what the actual indoor air quality is like. We
So,
recommended each of those people do an indoor air quality analysis.
and so
Um,
what is the term though? Because some will argue against that, making it too tight.
yeah,
And they say, well, you got to keep it somewhat leaky, but you're keeping it leaky in the areas that you don't know where it's coming from
right.
through rodent feces, through structural mold or mold in the structure or whatever, or some other contaminant. So you don't want to do that. So you want to make it tight, but ventilate it right. And that's the key for indoor air quality with whatever you're doing for sure.
Exactly. So if you have a house that's a good bit leakier than we'd worry about indoor air quality, because even after a 50% reduction or even a 75% reduction, you're well clear of 2 air changes per hour at 50 pascals. But if you're on that edge, then a mechanical only ventilation, which is using bath fans and using a range hood that directly vent, is not going to bring in enough fresh air to do the job. And then you need to move to a balanced ventilation system, either a whole house system or one of these spot ventilators like the Zender CA70 or the
Lunos.
Lunos or one of these other retrofit type units.
Yep.
So we're not just going to tell you, for instance, we're not going to walk in, find out your house is really tight, and say there's nothing wrong with your house. That's not the end of the story. We
Exactly.
still need to make sure that health and safety and durability, like Jim was saying, the tighter a house is, the more holds on to the stuff inside that and traps moisture, and we have to watch out for that.
Yes.
So, and after 2 weeks, we give an audit report, and that audit report outlines what we recommend doing, and if and some general guidelines on what those cost in the industry for people doing this type of work, professionals, and then we say, get in touch if those people that you hire need information or help or clarity, or if there's a follow up we need to do. Sometimes there's once in a while that we recommend that someone not make a change to their house, right? They have a new house or they just made a change to the house and they're like, well, what should I do? I think I should fix it. And we're like, you know what? We don't know how this is going to perform through all 4 seasons of a year. So just wait a
But Chris,
year.
we've also been honest enough to say, raise the house and start again.
Yeah.
We've had those issues too sometimes.
Yeah. What should I do? Run very quickly away from this house. Yeah. Yeah. So we're right up on the 8 o'clock hour. We've got an interview with Rob Conboy of Glavel, and he's going to be talking. He's going to be talking about some really interesting advances in sub-grade or below-grade insulation. So let's all take a moment and go ahead and listen to that. Is the representatives of companies that are creating new products, interesting products that we're pushing or liking, and we'll tell you about what it is and why. And today we're speaking with Rob Conboy from Glavel. And so welcome, Rob, to House Calls Vermont.
Yeah, thanks, Chris, for having me. Appreciate it.
Very happy to have you here. So Glavel is a product, a new product on the market. It is a below grade insulative material that we're looking at replacing plastic materials like EPS and XPS, and some people even putting rock wool below grade, which I think personally is about as nuts as something can get, because it doesn't absorb water. No, nothing like that does absorb water.
Or invite pests, but yeah.
Exactly. All the various things about why we wouldn't want to use a woven spun material below grade.
Exactly.
So introduce me to Glavel. I know quite a bit about it, but you and I have been talking for the past couple of years. So what is Glavel, and why should I care?
Yeah, so foam glass gravel is a product that's been on the market in Europe for over 20, 25 years. In my research of the product, I actually found an EPA report dated August 1977 that recommended that we convert our recycled glass, like Chittenden County solid waste glass, and turn it into the building material foam glass gravel, more than 40 years ago. So it's a product whose time has come. What's wonderful about bringing foam glass gravel to the U.S. and North America is that it's not a science experiment. We're standing on the shoulders of giants, European partners that have seen myriad of applications, including under footings and really leaning into the compressive strength properties of the product, issues like radon and how to put radon measures through the product. All of those things have been done over in Europe. So we're able to mitigate the adoption risk by working with our European partners on various use cases and how customers want to replace their nasty rigid foam board, as you mentioned, that comes with a ton of petroleum, ton of nasty chemicals that are pervasive in the environment, and we're burying this at an alarming rate underneath our buildings. And burying a product like foam glass gravel that doesn't have all those chemicals, it's naturally fire retardant, so you don't need to add those chemicals. It's obviously not petroleum based, so it has an enormous amount of benefits, especially when we think about the broader sense of healthy homes, not just the environment within the home, but what the home is sitting on is critically important.
Yeah. So tell me a little bit about exactly what foam glass is. Like, I understand that it is a vitrified, and please, we can go into what that means. But you start off with used glass. How does something get from used glass over to?
Yeah.
Yeah.
It starts with, like you said, recycled glass. We're going to be working with glass that's been cleaned to less than 1% non-glass, so paper or the off chance that there's plastic in the glass, and that gets ground into a fine powder, and that's kind of what the powder looks like. And that fine glass powder, to it you add a foaming agent. In our case, we're going to be adding glycerin, which basically, as the product rolls through a 25-meter long kiln at 15.
Wait. We don't say meters and then expect people to know what we're saying. So
75 foot, 80 foot,
25 yards.
Yes. So we have to convert to imperial units.
Yeah, you're good. Go on.
And at that temperature, basically the chemical reaction creates the bubbles, if you will, and the product starts out of, I almost said 2 centimeters, but it starts out about an inch or a little bit less than an inch, and then foams up about 4x. And by design, as the product leaves the kiln, there's a cooling table that allows it to rapidly cool down and fracture, creating these, random shaped aggregate, for lack of a better term, that then gets bagged up or bulk shipped to site.
So that's great. First of all, I also want to point out that this, unlike most of the building materials that we use in Vermont, you're building a factory here in Essex, Vermont.
We are.
So so this is going to be a locally produced product that you're hoping is going to be shipping all over the country and
exactly. And in order to minimize some of the risk of standing up that plant in Vermont, we have been working with our European partner to import product to get some demonstration projects launched here in Vermont. We have a project in Richmond that's coming up soon. And we will be doing demo days out at our plant once we have that product available from our European partner. So we'll be inviting out designers, excavators, developers to come out and play with the product and see how it actually functions. Because we are effectively removing the need for the gravel layer as drainage and the foam layer as the insulative layer. And replacing that with one product. And even before the current price increases of rigid foam board and the shock to the supply chain that occurred in February with the big freeze down in Texas, our product was at cost parity or a little bit cheaper depending on the size of the project in terms of the installed cost of foam glass versus the call it the traditional way of insulating below slab. So there's no green premium for what we're doing.
Right. What we're hoping with this product is that it's going to be a value added but not a cost added product, right?
Exactly.
And,
exactly.
And if it is truly a wash, then we're replacing stone, which is a quarried, a mined material, and we're taking the foam out of the entire waste stream. Never mind the fact that the most recent science is showing that microparticles of plastic are places where bacteria and other types of horrible things can grow in a way that we didn't know before. So when we're putting this plastic into the ground, what we're actually doing is loading our groundwater with microplastics for generations, right?
Exactly.
This is all just untested experiment we're doing on ourselves. So your product is something that takes a material, recycles a material, and produces what could be considered clean fill. Do I have that right?
Yeah, I would say that. I mean, we are definitely selling on the function of the product, not necessarily the form. But yeah, it's the value as an insulator. And in 2019, we committed to produce foam glass using renewable energy. So on top of the great story of taking glass that has little or no value and upcycling it into a valuable, useful building material, we're going to do it using renewable energy. So the result is an incredibly low embodied carbon building material as well.
So do me a favor, explain exactly how you're going to be doing it with alternative energy, how you're going to be using renewable sources for that process. Because generally, just like with cement, if you have to raise something up to 1400 2000 degrees Celsius, you're using natural gas. So tell me a little about that.
Yeah, so we basically opted to spend a little bit more money on the kiln and electrify the process. So yeah, you're absolutely right. Most kilns are gas-fired. Most foam glass gravel kilns are gas-fired. There are electric kilns in use right now in Finland and other northern countries where they have a lot of cheap energy. So we opted to switch to electric and then make sure that we can keep a price point and a cost that makes sense. But we believe in the long run that commitment to electrifying our production is going to be a huge benefit, not just to us and our operations, but also to our customers and the embodied carbon associated with their purchases.
This is exactly what we want concrete to be doing, right? We want to move away from there's nothing intrinsically wrong with concrete. The thing that's wrong with concrete is the amount of natural gas or other types of fossil fuels that are burned to keep that oven going for 3 to 5 days it takes to turn the base elements into Portland cement. So this is a great, I'm really glad that you went the extra yard here, now not extra meter,
no
but extra
intended,
yard, to make sure that you can look your customers in the face and with a straight face yourself say, we went the extra distance to make sure that this is a net zero plant on at least the making of the Glavel side. That's I didn't know that until just now, so I'm really excited about that part.
And I would say in a similar vein, our commitment around renewable energy, I think at the onset when we were researching the plants, we always sort of said, we'll go electric later. Let's just get the gas-fired plant up and running. But it became imperative to not push off those decisions, and you can blame it on Greta or, just renewed awareness of we can't kick the can down the road any longer. And I think in a similar vein, our commitment around doing our part to integrate the messaging and commitment around helping issues of social justice is also part and parcel of who we are. So very early on, we committed to working with an organization called Working Fields here in Vermont that places formerly incarcerated addicted individuals into positions here at Glavel. And we're also going to work with Vermont Works for Women. That also helps women in transition in their careers and in their lives, as well as trying to place new Americans into positions in our organization. So a deep commitment to social justice on top of everything else. So we tick a lot of boxes.
And workforce training. I mean, right now I'm running the apprenticeship program subcommittee for the Vermont Home Builders and Remodelers Association, and we're looking at three things. We're looking at where do we get people. We're looking at what do they need to be trained on, and how do we get that training done. And we look at where do these people work once we have them trained. The kind of the three parts of that particular stream, and all of the Working Fields and Vermont Works for Women, and looking at the resettlement programs here in Vermont for making sure that these underrepresented populations are given an opportunity. How many people are you going to have working at the factory?
Yeah, the factory will be right around 13 to 15 employees. It's not particularly labor intensive, but it is a 24/7 operation. So
3 shifts at 8 hours and the whole thing. Okay.
Yeah.
Okay. I certainly would love to get a tour when you're ready for it.
Oh yeah, absolutely. And like I said, we hope to be announcing, we're calling kind of our demo days when we have a couple of extra bags of product available to invite folks out over 2-3 days to come out and really experience the product, see how it compacts, how it behaves. We have, with early adopters, we've gotten quite a bit of feedback in terms of what it's like to, compact this Glavel that arrives has to be compacted by about 1/3. And, it's so lightweight, it doesn't really behave like 3/8 or any other stone.
Yeah. It's more like pumice when you're done.
It kind of, it floats and it just does take a little bit of getting used to. So we want to make sure that we remove any acceptance barriers if we can by inviting folks out to try the product out, that sort of thing.
I'm super excited about exposing the members of the Home Builders Association to this product, and hopefully we also have early adopters within the association. There are people who are like, yes, Gutex, yes, Glavel, yes, all of these new products. And so we'll have to make sure we tick those people, and hopefully they'll be able to move away from using foam and using this. I did see you sent over some great documentation, which will be available on the links under this YouTube video when we finally get it up. But they include pamphlets, and one of your pamphlets shows where do I use Glavel and how do I use it. And one of them was straightforward under a slab kind of situation, and the other one was as kind of a drainable fill to the outside of the wall above, outside of your wall above your drainage plane and your perimeter drain. So
exactly, and those are kind of the more straightforward applications. If anyone wants to put the foam glass underneath a footing, we do bring in engineers from Europe just to review what the expected compression strength is and what the load is going to be. Arthur at Duncan Wazinski was a very early adopter. I guess it was 2018.
Yeah, that was his house over on.
Yeah, exactly.
Yeah.
So he used
Arthur
it
Chuckman. I just wanted to make sure we got the full name out there.
Yeah, thank you.
Yeah.
Under the footing at his amazing addition that he did here in Burlington. I should also mention, you touched on concrete. Myself and Russ from Engineering Ventures, we did a panel at Passive House, Maine, And Russ is very excited about the applications of foam glass gravel and the ability, because of its compressive strength, to minimize the use of concrete. So if design called for, say, 6 inches of concrete on foam board that has a compressive strength of 40 or 50, because foam glass gravel has a compressive strength of over 100 pounds per square inch, the ability to remove some of the concrete needed is an exciting proposition.
So you're saying a thinner slab would be needed
Exactly.
under those conditions. Okay.
Yeah, yeah. And, new frameworks we've even seen where, a typical 6-inch stem wall, they did a project recently that they had Glavel under the slab, but they were, doing a 4-inch stem wall. So again, just being, questioning kind of the rule of thumb. That's how you always do it. That's what the forms are. The forms are 6 inches, so we pour 6 inches of concrete. Everyone's really starting to question what's always just sort of been a rule of thumb,
Right.
When you're looking at all of these designs and details through the lens of minimizing the embodied carbon.
I'd love to see, I mean, oftentimes, just like when we went to a 2x6 wall,
Yeah,
there's no change in the structural ability of a 2x4 wall to hold up a 2 or 3-story house, 16 on center, 24 on center, advanced framing, all of these things that we're trying to do to get more out of our resources and have less
exactly.
embodied energy in the materials we're building with. Those are all goals that everyone would agree to, although everybody will have a different opinion about the adoptability and when to adopt that. We're now in a place, oddly enough, with the new Arby's code, where it makes more sense to build with a 2x4 wall and do an amount of rigid insulation on the outside to get to that R25 wall, because of the building science of the first condensing layer. You have a 2x6 wall, you need half of that to be rigid on the outside, so you have an R23. You have to do R23 outside to make sure
Exactly.
it's going to survive. Well, let's just build a 2x4 wall, so that's an R13. Double that R on the outside, and we're at an R26, which is above code by a little bit at this point. But yes, the same type of adaptation. Or adoption, not adaptation.
Yeah.
I'm making
Have
up words as we
you
go.
have you seen presentations by Chris Magwood and Ace McCardle on how well they articulate the embodied carbon question, and how with a little bit of homework, being able to make dramatic impacts on the embodied carbon. I highly recommend.
So, to be honest, both Ace and Jacob are on my list. I don't know which one of them I want to have on.
I would have
Both
them
of
both on at the same time.
They're great. I've been a follower, a friend, and an advocate for new frameworks for a very long time. So I'm definitely going to be ticking them to talk about a number of different things. Not just the embodied energy, because I think, and the CO2 sequestration that they're talking about, I think is a very important point. Jacob is a part of the most recent advisory board on the newest code. We're having deep discussions, and he's trying to bring in embodied energy. This is the second round where he's bringing it up, and
that's great.
And there's traction now, not for making it required, but the new code has a point system. You have base, and you have to add points. We're thinking about incorporating points to allow for that ability to take points or add points to your goal of hitting your minimum code by looking at embodied energy, which is brand new for us as a state, and probably brand new for the country in a lot of ways. And in that way, Vermont can be a leader again.
Yeah, I highly recommend folks playing around with the EC3 platform. So I guess it was fall of 2019. The partnership between Microsoft and Skanska, they put some money into creating a platform where the aggregation of all the EPD reports for materials that were fairly standard. They created this massive database where you can go in and play with here's my detail, this is what it's calling for, and it spits out the embodied carbon of that detail, and then you can start tweaking it. What if I, switch to rock wool, or, make some changes? How does that impact the embodied carbon? It's an amazingly simple and powerful tool to use.
It's also a hard sell with a lot of builders, because builders are not there at counting embodied energy. This is really what we call bleeding edge stuff. But it's important to have the bleeding edge so that it becomes the leading edge and then can become easily adoptable.
Yeah, and that's what's sort of fun about Glavel is, because it isn't a cost premium, because it's a easier product to install, they get the benefit of the embodied carbon story without even trying. They fall backwards into it. Instead of, it being the leading thing, they by default get all that benefit without even asking for it.
So let's just talk a little about the actual building science information about this. You already mentioned the compressive strength, which on your documentation is listed as like 118 pounds per square inch.
That's correct. Yeah.
If I remember correctly. What's the R value? Because a lot of people are going to say, look, I'm used to putting an R5 product on. That's 2 inches of R5 or 3 inches. That gets me there. What's the R value per inch of compacted Glavel?
Yeah, the installed R value is 1.7 per inch, and we plan on sticking with that R value until we have our domestic production up and running, and we hope to be inching that R value up, by, say, Earth Day of next year. But yes, it's about our 1.7 per inch installed. The loose, if you were to just install the Glavel on the outside of the frost wall without compacting it, it's about 1.3 per inch.
Okay. And as with any insulation, you're actually insulating with trapped air, right? That's in the end what we're doing. Yeah,
both trapped air inside of the
and between
each piece, and then in between, exactly.
Right. Interstitial and internal.
Exactly. Right. Yeah. So if you're doing very detailed energy modeling and you have very specific targets, being aware of water table. So is there going to be times of the year where that R value is going to be hindered because of the water table? Factoring that into the amount of insulation that you install is important. What I point to is a lot of anecdotal evidence about the diminishing returns of foam board over time.
You're reading my mind. I was about to say what happens to XPS when it's submerged for 2 years.
Yeah, I mean, we have so many, pictures of ants living in XPS and EPS. We know it gets soggy. We know that we sort of bury it and forget it and say, oh, we built an energy model off of that, but how does it actually perform?
Yeah.
I would love, this one of the studies I'd love to see is, looking at the performance of slab on grade foam board over time to see what kind of R value it's really achieving. But just, again, anecdotally, we have to believe that it's going to degrade over time. Whereas insects, rodents aren't going to live in foam glass, and it's not going to break down over time.
Right. It is itself not a foodstuff. It's not a right. I remember when I was first doing WUFI analysis, and they're saying the absorption of fiberglass is 0 because glass has an absorption of 0, and I'm like, no, I'm sorry. I pull out sopping wet fiberglass from cavities all the time. It's not the glass that I'm worried about. It's the interstitial spaces that traps the gas that we're using to insulate. That's the problem. So I'm 100% with you. We're constantly looking for good information about the degradation of a rigid foam insulation that does not have good drainage or a dimple mat, and you can keep it dryish, right?
Yeah.
So you can do a lot of things to keep an XPS or an EPS in good shape. I don't see that in the field. When I'm doing audits, I do not see people installing dimple mats and drainage planes to make sure that
all that gets valued engineered out.
That's right. Well, or the people who did it didn't know it and they needed it to begin with, which is more often the case. Oh, the code says 3 inches of XPS. Let's get the blue board, put it on,
Yeah.
backfill against it, and we're done, and we're good. So
Yeah.
that's another nice thing about Glavel is that we should not see a degradation due to off-gassing, right?
No.
All of these EPS, XPS, and other foam board insulations off-gas and
Yep.
lose their ability to do the work that they were designed to do over years. And that won't happen with this product as far as I
Exactly
can tell.
right.
No.
Yeah, yeah. And, when we've got cases, things like radon. So foam glass gravel, you can actually, run your radon piping
Right
through
in
the
it,
foam
right.
glass, no problem. If you are doing a high performance building and you are really concerned about the true R value and the performance of the R value below the slab, we have had questions, and we worked with Andrew Webster very early on. We had a question about active radon measures. So if you're actively drawing air through a radon measure, that will diminish the R value for a certain square footage around the pipe. So again, if somebody is high performance building and they are putting an active radon measure in, the recommendation would be, let's just sort of calculate, how long is the radon pipe and how much R value do we have to make up? We again kind of use a rule of thumb that the equivalent would be if that Glavel was wet. So we bring it down to R1.3, which I think is really, really conservative. But again, these are, high performance builders who have done all the different modeling, and we want to make sure that they get the R value that they're expecting over time. So,
which is not what I'm getting when I talk to Owens Corning about their pink board. They're not worried about that at all. They're like, okay, the R value tested at 74 degrees Fahrenheit is this.
Fine.
We're good.
Exactly.
That's one of the things about the hegemony of an existing product, right? It is assumed to be already tested and up, down, and left and right. And when you bring in a new product, they'll be asking you questions that these other products were never asked to answer.
Right.
Like the uptake of moisture in a below grade EPS or XPS. The off-gassing question, the difference in temperature of R value depending on temperature, like we know with polyiso, how it goes down as the temperature goes down. So
yeah, and it is a funny thing too, because you are literally burying it and forgetting it, right? Yeah. You just sort of bury it and assume it's going to do what it said it would do, and no one's ever complained about it before, so it must be doing something. Time.
No one's ever complained. I'm like, have you gone back and looked? No. Well, a homeowner is not going to complain. A homeowner doesn't have that. As I've said before, the homeowner assumes that the builder is the adult in the room. This is the person who has the information.
Exactly.
And if I am questioning that, I need to have a basis of information, of knowledge, which is really what House Calls Vermont is all about. We're really about letting the consumer start to understand the building science so they can make intelligent questions and bring up concerns to a builder that a builder may not themselves know in a state like Vermont, where they're not required to know anything.
Yep.
kind of. Well, Rob, that's kind of all the time we have for this. Thank you so much.
Yeah. Thanks for having us. And if people have projects, our typical process for walking them through converting from foam board to foam glass gravel is, starting with the details. What are they traditionally looking at doing, and then we can help.
People have projects, our typical process for walking them through converting from foam board to foam glass gravel is, starting with the details. What are they traditionally looking at doing,
so you can just look at the name.
People have projects, our typical process for
Rob Conboy from Glavel Incorporated here, being built and manufactured here in Essex, Vermont, a local product. I couldn't be happier that you're getting so close to actually having the factory up and running. It's taken, what are we talking now, 4 years that you've been working on getting this together?
I first was introduced to foam glass gravel in Darmstadt, Germany in 2016. So over 5 years from introduction to actually having a plant up and running. But who's counting?
Yeah, well, yeah. You have children, and if I remember correctly, small children still. I think your youngest child is 7 or so now.
Yeah, exactly. Owen turns 6 in December.
Oh, there you go.
Liam is now driving, so that's terrifying.
As are my kids, all of them scary. Well, Rob, thank you so much again for taking time out. And when the factory's up and running, I want a live tour of it that we'll broadcast over the airwaves here too.
That sounds great. Thanks, Chris. Appreciate it.
Thank you very much. You're very welcome. Have a great day. So this is Chris West from House Calls Vermont, and if you have questions about Glavel, questions about details, please feel free to shoot us an email at housecallsvt@gmail.com. And you remember, you can always call in during our show times. That's Tuesday evenings from 7 to 8:30 p.m. on our YouTube channel. Just type in on a Google search YouTube House Calls Vermont and you'll bring it up. And the number there is 802-200-2550 if you want to call in with your question.
I hear you.
We'd be happy to answer it. Thank you very much. And until next time,
can you hear me?
This is Chris West. So here we go. We're at the very end of the show. Thank you very much. We're still ironing out our technical things, as we say. And if anybody's interested in getting that particular interview with Rob Conboy from Glavel, that'll also be a separate video on our YouTube channel. Do a YouTube search to find it, House Calls Vermont YouTube, and it'll bring you right to our channel. And we'll be back next week with another show. We didn't quite completely finish the audit, but we'll make sure there's a copy of a redacted audit so that you can't see any of the personal information about the people, but you can see the type of things that we provide when we do an audit. And we consider our audits to be pretty thorough. So Jim, any thoughts on the Glavel?
Oh my gosh. I mean, didn't know much about it before, but even seeing your interview with him, I'm intrigued. And I have a build starting on Thursday, and I want to see if I can incorporate that at the same time because, using resources, repurposing resources at the same time without wasting them would be so much better. And especially if the performance value is there at the same time. And so, I think this is great. I want to do a factory tour. I want to find out what is going on with how their process is moving forward with, and at the same time get that out to the nation. Quite honestly, what's available.
Yep, yeah, this is a very exciting development for us in the building environment. And if you have a project, and part of that project is going to be below grade insulation for on the outside of a slab or the outside of a wall, it doesn't really do quite well inside, but this is a great product to look into. You can give Rob drop him a line at glavel.com. And until next week, this is Chris West.
And Jim Bradley as well, and we'll see you next week.
Have a good week, everybody.